in the lesson on combining functions, Rock 12 5.1, and then we'll jump into the book work. It's quite a bit of book work today, so we'll see how that proves this as to whether we need to break into groups or not. So
test should be up shortly. I'm getting them uploaded.
What's that?
I was telling them the test. They're test shortly. I got them graded. I just got to get them uploaded and get the grade in there, basically.
And our next test is this coming Wednesday. If you want to take it during class time, if you are planning on traveling or you just don't want to take it that day, you're going to be cooking all day, then you can take it right after the review on the 24th.
And I did look over that one more time, and it looks good. So.
Looks okay. Okay, good.
Yeah.
All righty then. Music. I do have other game apps that I know how to use, but this one is like the quizzes and all those, it's like everyone's working independently, and I'd rather be able to stop and explain a problem as we go. So I'm trying to, I know some of y'all might be tired of this format, but it seems like it, for my personality, as far as teaching goes, it works the best of the ones that I have. When I'm in an actual classroom, it's easier to do different things like clickers and stuff like that, which are super fun, I think, but it's hard to do that remotely. And just saying, for those of you that are really consistently doing your homework, I know when you look at the grade breakdown, the homework is worth 15%, but really when you think about that, that is pretty much equal to a test, and it can make the difference between a passing and failing grade for sure. So just encourage you to keep that up, and it is very worthwhile for you to do it. I would encourage all of you to also participate in the Kahoot if you possibly can. Get into the game. That's really good. And I've been really impressed. Most of you all have been super good about turning in the classwork. And I know we do it together, but you show your work. It always looks good. And then the written exercises too. I feel like you do a good job with that if you're doing it. And I hope that if you have questions about it, that you'll make a point of asking. Okay, I'm going to go ahead and get started. And if you want to jump in, if you're not here already, then feel free to jump in whenever. And if you aren't on the board, please follow along. So g minus f of x, and where f of x is square root of x plus 1, and g of x is square root of x minus 5. Okay, so what you have to remember is that whenever you have g minus f of x, that's the same thing as saying g of x minus f of x. And since g of x is the square root of x minus 5 and f of x is the square root of x plus 5, what we would have is the square root of x minus 5 minus the square root of x plus 1. And that would be the square root of x minus 5 minus the square root of x. Don't forget to distribute that negative, minus 1. And the square root of x's will go away and you're left with negative 6. So if you picked negative 4, you probably did not distribute the negative. And if you picked 6, you probably did f of x minus g of x. The order does matter. Okay. So let's look at this. Okay, so so remember the rules for combining functions. F plus g of x is f of x plus g of x. F minus g of x is just the same thing as taking the functions and subtracting them. F times g of x is just the same thing as f of x times g of x. F divided by g of x is just the same thing as f of x divided by g of x. So these are just shortcut ways of writing what's happening with the functions, because mathematicians get lazy and they don't want to have to continually be writing out the long version. So a lot of times we come up with a shortcut. So f times g of x, where f of x is the square root of x plus 1 and g of x is the square root of x minus 1. We're going to just use the distributive property. And if we take the square root of x times the square root of x, that would be the square root of x squared. And then the square root of x times negative 5 would be negative 5 times the square root of x. And then 1 times the square root of x would be plus 1 times the square root of x. And then 1 times negative 5 would be minus 5. Anytime you have the square root of a square, they're each other's inverse operation, so they undo each other. So that would be x, and then this would be minus 4 square root of x. And that would be minus 5.
Did you notice the notes for the composition of function didn't have the composition of function symbol?
I did notice that. I'm like, okay, I know it's got.
And I ran out of ink like in the middle of doing those notes, so I had to switch the marker.
Yeah, well, I figured that you would clarify that for them. Good. Okay, so this one, this is just g divided by f of x, where f of x is square root of x plus 1 and g of x is the square root of x minus 5. And so all you have to do on this one, and we're not going to make you rationalize the denominator. You can leave the radical in the denominator if you want. So in this case, you'll just take the g of x, put it on the top, and the f of x and put it on the bottom. But what you have to remember is you can't cancel, like you can't just cancel the square root of x's, because remember that they're tied together by the negative right here. And these two are tied together by that negative right there. So you can't cancel from here. You just have to leave it like that. Good, most of y'all got that. So f plus g of negative 2 would be f of negative 2 plus g of negative 2. F of negative 2 is just 0. You'll go to the x value, negative 2, and whatever the y value is, that's what you're looking for. So f of negative 2 is 0. And then g of negative 2 would be negative 1, 2, 3, 4. So 0 plus negative 4 would be negative 4. G divided by f of 0. Okay. So G divided by f of 0. G of 0 you go to 0 and then go to the G graph would be -3. And then f of 0 would be 2. So G of 0 divided by f of 0 would be -3 over 2. Let's look at this. So f of x squared of x plus 3, g of x is 1 over x squared. This means the same thing as g of f of 4. That is not a time sign. That is a composition symbol. That means what it means is that you're going to take the f function and plug it into the g function. You always start with the innermost function, and it can be written like this too, which is how I prefer to write it. You always start with what's inside and then work your way out. So I'm going to start with the f of 4. So that means I'm going to plug 4 into the f function. So that's going to be the square root of 4 plus 3, which is 2 plus 3, which is 5. And then I'm going to take that 5 and plug it into the g function. So g of 5 would be 1 over 5 squared, which is 1 over 25. So this means you're combining the functions using a composition. You always start with the innermost function, find it, and then whatever number you get, you plug it into the other function.
Yeah, we only do this like composition with 2 functions, I think. I don't think we go up to do more, right?
No, I mean you can do infinitely many compositions, but I think the most we do is 2.
Yeah,
it can get pretty gnarly. But
yeah, it's a bit backwards from what we usually do things. We usually read things right, left to right. But like when we do compositions of functions, we read them right to left, and I think that really trips people up because they have they got 18 years of conditioning left to right.
Yeah, well, that's why I like this better, because the way it's written kind of tells you that you're plugging this into that. But the way this is written is counterintuitive, I think, too.
Yeah, I try to really emphasize in the notes, write out your definitions, and you will probably get it correct if you look at it.
Just the main thing people do is they want to think this is a time sign. Don't think it is. It's an open dot. If it's a closed dot, then it would be a time symbol.
Is that square root of x plus 3? Or is
That
it,
is.
I'm sorry, f of x, or, so the square root does not cover the x and the 3?
That's correct. Just the x.
Okay, okay, thank you.
Okay, so this time we have g of f of x, which means that we are plugging the f function into the g function. So the first thing I'm going to do is take f of x, which is the square root of x plus 3, and I'm going to plug that into the g function. So g of f of x is going to equal to 1 over the square root of x plus 3 squared. Now remember, you can't just say that's x plus 9, because what that actually is the square root of x plus 3 times the square root of x plus 3. So you just want to leave it like that. Let's look at this. So this is f of g of 3. So what are we going to find first here? What would be the first thing we would find? Always work from the inside out. So the first thing you're going to find is g of 3, right? So let's look at this. So g of 3, we go over to the 3, and then we go to until we hit the g function, and you look at the y value. So g of 3 is the number 1. And you're going to take that number and plug it into the f function. So you're going to go over to the number 1 and then match that to the f function, which is at 4. So if you look at this, so f of g of 3, the first thing you do is you find g of 3. G of 3 is the number 1. And then you take that number 1 and you go over to the 1 and you match it to the f function. And the y value at that spot is 4. Okay. And last problem here. G of 2. Good. Okay, so g of 2. First thing you do is go to the g function and go to 2. And you see that the y value there is 0. So then you go to 0 and then you go back to the g function again, and you wind up at -2. And surprise. Good job, you guys. And I hope that helped clarify a few things. All right, so now let's take a look at the homework. So if you'll get your homework out. Okay. So f of x equals 2x minus 3 and g of x equals 1 minus x squared. So remember, by the rules of combining functions, f plus g of 3 is the same thing as f of 3 plus g of 3. So what do you get when you take f of 3 plus g of 3? What is f of 3? What y'all get for that? I'm going to call on people. And if you don't want to answer, you can just say, pass me up. Michael, did you get f plus g of 3?
Which number is that?
7a.
Okay, so we're gonna take 2x minus 3 and then add it to
Mhm.
1 minus x squared.
Right.
Okay, I'm gonna reverse the symbol of the minus x squared because of the addition, right? So isn't that gonna change the symbol? Or does
No,
that still
okay.
make it minus? That still makes it
Right.
minus, right? Okay, because we're
Right.
not subtracting, okay. I can take the -3 and I can make that a -2 because I'm combining it with a +1.
Okay, so
And
can you see my screen?
yeah,
Okay, so f of 3 just means you're taking that 3, right, and plugging it into the f function. So that would be 2 times 3 minus 3.
oh, okay, so first we do that, okay.
Yeah,
So that would
yeah.
be 6 minus 3, which is
Right.
3.
Uh-huh.
Okay, and then 1 minus 9, which is
Which,
-8.
yes.
Okay, so 3 plus -8 is -5.
Yes, thank you. Okay, so let's keep going. I'm going to stick with you, Michael, if that's okay. What about f minus g of -1?
Let's see here, that would be -2 minus 3, which is -5. Let me go over here. That's, well, this is kind of weird because I guess that would make it a +1, but then the negative would
Yes.
turn it back into a -1. So that's 1 minus 1 is 0. So all you're left with is the, I can't remember what this, oh, -5 over here. So that's it. -5 again
Yes.
is what I got. Okay.
Good. Right. Then what about f times g of 0? Now, sometimes, guys, there might be a little time sign in there. So, and that's fine. if the only time that it's not going to be multiplied is if it's got the open dot, looks like fog kind of. Okay, so what is f times g of 0? Michael, I'm sticking with you.
-3. That's what I got,
Okay. Yep.
because you
you're
just have
right.
-3 times 1, so.
Yep, that's right. All right, and finally, what is f divided by g of 2?
And let's see here. -3. What was this again? 1. And -3. 1 divided by -3. I can't simplify it. It's just -1/3.
Okay, so it's
I
going
can't
to
take any
be,
further than that.
yes, you're right. Because 4 minus 3 is 1, and 1 minus 2 squared is -3. So that would just be -1/3. Exactly. Good job.
Okay.
Thank you. Okay. So here we're doing the same thing with number 13. Only this time we're just using the x. So f plus g of x.
Oh, you want me to do that?
No, I'm not gonna make you do
Oh, okay.
the whole lesson. Thank you though, Michael. F plus g of x means you would just take the f function and add it to the g function. So August, you're next on my list. So what did you get for that, for A, f plus g of x? Are you with us, August?
She's entering in the chat. Oh, she has to be good skipper. She's answering in chat.
Oh, okay. I'm not looking at my chat. I need to do that. Oh, of course up. But August, can you see my screen? Okay, so what is f of x in this problem? What is f of x? Okay, I'll come back to you. Aurora, can you help me with this one? What is f of x in this problem?
3x.
3x. And what is g of x?
1 minus x.
1 minus x. And if you combine those two, what would you get?
1 plus 2x.
All right. You're just adding those polynomials, right? So you get 1 plus 2x or 2x plus 1. Either one would be acceptable. All right, so what about f minus g of x? What would you get? August, I'm sticking with you.
You mean Aurora? That's what we meant.
I'm sorry, I'm in Aurora.
Oh, okay. 4x minus 1.
Say that again. 4x minus 1?
Yes.
Yes, because you're distributing that negative, right? And so that's going to be that a positive x. So that would be 4x minus 1. Good. Okay. Okay. Aurora. The AUs, I don't know why that's just my. So Aurora, what about f times g of x?
One second. that's gonna be
You're just going to distribute that 3x, right?
so is it negative 3x squared plus 3x?
Right, plus 3x. Right, so you're just multiplying those polynomials. And if you multiply 3x times negative x, I like it. I like how you put the higher exponent in the front. But if you didn't, I would not have counted that wrong. And 3x times 1 gives you the 3x. And finally, f divided by g of x. What would that be, Aurora?
It's gonna be 3x over 1 minus x.
That's right. And you just leave it like that. There's not anything you can do with it after that. Good job. Thank you. Bree, do you want to help me?
Yes.
Okay, perfect. Thank you. All right, so 21, we got some radicals, but don't let that scare you. So the first thing we're going to do is the f plus g of x, right?
Oh yeah.
And what would you get if you added the square root of x minus 1 plus the square root of x plus 1? So if I add the square root of x plus the square root of x, how many square root of x's do I have? It's like if I'm adding one cow plus one cow, how many cows do I have?
2 of them.
Yeah. And then if I add the negative 1 and the positive 1, what happens?
It cancels out.
That's right. Right.
Okay.
Good, Bree. So this is it. When we have f plus g of x, that's going to be it. 2 root x.
Okay.
And so b is f minus g of x. So just be careful because on this one, you're going to have to distribute the negative. Okay. Don't forget to apply that negative to every single thing in the second polynomial. So what would you get when you have square root of x minus square root of x?
Wouldn't it be like a positive or?
Yeah, -2. It's because you're adding. What's
-2?
-1? Yes, right,
Okay.
-2. The root x's go away and you're left good. Okay.
Okay.
And then f times g of x. So what are you going to do on this one? What's the little acronym we use for using the distributive property? FOIL?
Oh, okay.
So what is square root of x times square root of x?
X squared.
Square
Or
root of x squared, which is just
X squared.
x, right? Because anytime
Yes.
you have the square root of x squared, the square root will undo the x squared. So you're just left with an
Okay.
x. And then outside times outside?
Just be 1 or
One square root of x,
1.
And then inside times inside?
Would it be the same thing? 1 square
Minus,
root of
only
x
minus,
minus, okay,
and then negative 1 times 1.
would 0?
Oh, you're
Or-
multiplying.
Oh, 1,
Yeah, negative 1.
negative 1.
Right. And so that's going to give me, what happens to those square root of x?
They cancel out.
They do. And you're just left with x minus 1. And then finally, d, f divided by g of x. What would go on the top?
X minus 1.
The square root of
Or
x
square root
minus 1,
of
huh?
x minus 1.
Right. And on the bottom?
Square root of x plus 1.
That's right. Good. Square root of x plus 1. And you can leave it like that. Okay, we could rationalize the denominator if we want to, but we're not going to on this problem. Okay, so now we're on 23. So Elliot, will you help me with 23?
Yes.
Thank you. So f of x. So what would f plus g of x be?
So would you add the numerators together?
Absolutely, because we already have a common denominator, right?
Yeah.
So what would you get?
4 over x plus 1.
Perfect. Okay, so then what about f minus g of x?
Is the 3 supposed to be on the bottom? Oh,
No,
okay. I was confused for a second.
sorry.
Fine. You would get negative 2 over x plus 1.
Beautiful. All right, then what about f times g of x?
Wouldn't that just be 3 over x plus 1?
3 over x plus 1 squared, right? Because when you multiply fractions, it's top times top, bottom times bottom.
Oh, okay. Okay.
So really, multiplying and dividing fractions is easier than adding and subtracting fractions because you don't have to worry about common denominators. You just multiply straight across, top times top, bottom times bottom. All right, and then finally, f divided by g of x. When you divide, what do you have to do first? It's the first thing you always have to do when you're dividing.
I'm not sure about that.
Okay, so remember that division is going to be just like multiplication, only you have one extra
Oh, you
step.
you have to flip it.
Yes,
Like that.
that's right. Okay, then what happens here?
Then you multiply the top and the bottom.
Okay, so,
So you would get, yeah, 1 of x.
and then what happens there? Can we cancel anything?
you can cancel the x plus 1.
Right. And when we cancel and everything goes away in the numerator, what do we replace the numerator with? What number?
1.
Yes. Thanks, Elliot. Good job. Okay. Now, for some reason, do not ask me why. I put 37 and one other one. I just left them off, but they are important. So I did include them. So let's go to 37 on this. Okay, Hunter,
Yes, ma'am.
can you help me with this one?
Yes, ma'am.
Okay.
So 37A is f of 2 plus g of 2.
Yep.
Let's see. F of 2 is going to be 4.
F of 2 is 4.
And then the g of 2 is negative 2.
Negative 2.
And the answer to that is 2.
Right. Okay. And then F of 1 minus G of 1.
Yes, ma'am. Let's see here. F of 1. F of 1 is 1 minus negative 3.
Yep. And so what does that give us?
Four.
Okay. And then F times G of 0.
Sorry, I'm writing as we go.
Oh, that's fine.
F of 0 is 0.
Yep.
And g of 0 is negative 4. And that's going to give us 0.
Yeah. 0 times anything is 0. And then F of 1 divided by G of 1.
One divided by negative 3.
Yep.
That's negative 1/3.
Yep. Great. Awesome. While we're on this page, let's do the composition functions too, so we don't have to come back to them. So remember compositions, and I'm gonna hang with you, Hunter, for a minute. Compositions mean you're taking this one and plugging it in to that one. So tell me, what is G of 1?
G of 1 is 2.
Is 2. So now what are you going to do with that 2?
Plug it into the, or find the value of f at
Right.
2.
So we're going to take that 2, and now we're going to look for F of 2.
Which
and what is F of 2?
Negative 3.
Negative 3. F of 2. Here we'll go here to go to the F function, and that would be negative 3. Okay, great. All right, what about G of F of negative 2? What are we going to find first?
The f of negative 2.
Right.
Which again is negative 3.
So F of negative 2 will go over to negative 2. We'll drop down to the F function, and that is negative 3. And then what?
We're going to find the value of G at negative 3.
Yes.
Which is negative 2.
Yep. So now we're going over to negative 3, dropping down till we touch the G function, and that would be negative 2. So that's our final answer, right? That's it.
Yes, ma'am.
Yeah, okay, now finally g of negative 2.
G of -2 is -1.
So g of -2, if you drop down, you wind up, oh wait, yeah, right. -1, right. And then what?
G of -1 is 0.
G of -1 would be right there, and that is 0, and that is my final answer. Great. So all you're doing is you're finding the second function first, and whatever you get there, you're going and plugging that into the first function. Okay, let's go back to other homework. Okay, Monica, can you help me with this?
Yeah, I can help, but I don't really know much. about
Okay,
it.
that's okay. We'll work it together, okay? Is that okay?
Yeah.
All right. All right. So first of all, I want f plus g of x. Okay, so that's the same thing as f of x plus g of x, right?
Yeah.
So what is f of x in this problem? What? Oh, wait. We want f of plus g of 0. So what is f of 0?
0.
Okay, so look, what you're doing is f of 0,
Oh.
it would be, what's the y value that it's paired with?
4.
4, yes. And then what is g of 0?
2.
2, yes. And that would just give us
6.
6. Perfect. Okay. Now we want f. Oh, I gotta pay attention here. Now I want g minus f of 5.
3 and 1.
Okay, so g of 5 is 3. And f of 5 is 1. So that gives us
2.
just the number 2. All right, now C, I want g times f of -5.
-3 and -1.
Right. Ah. All right, and finally, D, I want g divided by f of 5.
So 3 and 1.
So that would be 3. Oh, wait. Okay, so which goes on top?
1.
Right, because it's g of 1 is 1.
Yeah.
And f of 1 is 3. Great.
Miss Watson, for B, shouldn't it be 1 minus 3 equals -2?
Oh, yes. Absolutely. Thank you. See that? Because the g function is in front, right? So g of 5 is 1 and f of 5 is 3. So it should be 1 minus 3 is -2. Thank you very much for pointing that out. All right, what's next? That was 37. We already did 37. 4361. Okay, so now we're on 60. And Olivia, will you work with me on this one?
Yeah.
Okay,
I'm
great. Okay,
very
so
good with
f
these ones.
of g of 2. What are you going to do first?
Find the values for 2. F of
Find
2,
which
-2.
one? F or G?
F.
Okay, so when you have a composition function, you work from the inside out. So you're first going to find g of 2. And then you're going to
Um,
plug it into F.
Okay.
So what is G of 2?
Well, it would just be 2 squared, so 4.
2 squared, right. And now you're going to take that 4 and plug it into the F function. So what is F of 4?
Square root of 9.
Yep.
So 3.
So that is your final answer right there. Okay, good. All right, and then B, that was A. B is,
So we would find f of -1. first.
right, good.
So -1 plus 5 would be 4. Square root would be 2. Yeah, 2.
Uh-huh.
And then do we plug it into the g of x?
That's right.
Okay. And
What are
then
you
it
going to
would be
plug
2
into the
squared
G?
still.
2,
The 2, and then you would get 4.
right. And that is your final answer. Okay. Thanks, Olivia. Timothy, will you help me with 75?
Sure.
Okay. So here we're finding these things. The first thing we're going to do is find f of g of x. So what is that telling us to do?
Well, we're gonna multiply.
That's not multiplication. That's the open dot is a composition.
Okay.
And what it does is it tells you to plug the g function into the f function. So what is the g function on number 75?
5x.
5x. You're going to take that and plug it in for x in the f function. So what's that going to give you?
1 over 5x plus 1.
Perfect. All right, then they want g of f of x. So this time, what are we going to do?
I'm just gonna put f inside of g, obviously.
So you're right, exactly. You're going to take the f function and plug it in to the g function. So that's going to give you what? 5 times
1 over x plus 1.
Uh-huh.
And you,
Just 5 over x plus 1, right? Because this is like over 1.
yeah.
Okay. And then finally, f of x. Tells us to do what?
Yeah, I put 1 over x plus 1 into x plus 1.
Uh-huh. Plot take the 1 over x plus 1. This is going to look really ugly. Tells us to take that and plug it in right there. So we're going to have 1 over x plus 1 plus 1. And if you're checking in the back of the book, they may have simplified that, but don't worry about simplifying that. Just leave it.
Sweet.
Okay. Can you hang with me for a minute and do number 81?
Why not? Okay.
Okay, so what's this telling us to do? Take what and plug it into where?
Take f and plug it into g.
Okay, watch it. Remember, you're always starting from the inside. So this is telling you to take g and plug it into f.
All right.
So what I do is I always just take whatever the x is in the f function and just put a big parentheses there, and that's where you plug in the g. Now we can simplify this, right?
Yeah,
What happens to the 5s?
they cancel out.
Yes.
And then you got to distribute the -1 inside the
Good,
paths
yes.
twice.
So what do you wind up with?
X.
Just x. And tomorrow's lesson we'll talk about, that's special because we wind up with exactly what we started with. Okay, so now we want g of f of x. So which one are we going to start with this time?
F of x.
And we're going to do what with it?
Plug it into G.
Plug it into G, right? So I'm going to take G and just put a big parentheses. And that's where I'm going to plug the f function in.
I'm writing it out as
Oh, yeah.
1 minus parentheses.
Oops, I'm looking at
1
it the
minus
wrong way.
5x over 5.
Yeah, so f of x into g of x. So that's going to be 1 minus 5 times. Is that what you just said?
Yes.
X.
That's the way I wrote it.
Oh,
Over.
sorry. Yeah. I'm confusing myself. I'm looking at the wrong one. Okay, so
It's all good.
we're plugging it into the g function, which is 1 minus big blank over 5, right? And so you said
Right.
to plug 1 minus 5x in here, right?
Precisely.
Perfect. Okay, then what?
Well, you can distribute the
Uh-huh.
the 1. So it'd be 1 minus 1 plus 5x over 5.
Yep.
And then you can simplify across 0. I mean, 5x over 5.
Mm-hmm.
And you should come out to a single x.
Single x, right? Good job. Okay, and finally, f of x.
Running out of room. Okay. Well, holidays to get sick. All right. So it's going to plug in. That's so 1 minus 5 parentheses 1 minus 5.
Good.
And as for this one, I'm just distributing the -5.
Right.
It should become -5 plus 25x.
Yep.
And then you just subtract the 1 from the 5 and you come out -4 plus 25x.
Perfect. That's your final answer. Right. So we're down to 91. And I'm going to go back to the top. Michael?
Sorry, I have a little issue here. 1 second.
Okay.
Sorry, I need to skip this one. I apologize.
Okay. That's no problem. Timothy,
Sorry?
can you help me with number 91?
Sure. Why not?
Okay, g of f of 0. So what would g of f of 0 be?
G f of 0 is so in the f of 0. 0. Give me a second. Okay. GF of 0. So you're going to do 15.
Okay, so what is
Parentheses,
f?
0.
What is f of 0?
F
Because
of
you always
0?
start with the innermost one.
So I got 5 for that.
Yep. So f of 0 is 5. And what are you going to do with that 5?
You're gonna plug it in with g of f, g of 0.
And so what do you get when you plug 5 into the g function?
20.
Okay, wait. Okay, so you got 5, right? When
Yeah.
we said f of 0 is 5. Now we're going to take that 5 and we are going to find it in the g function. So when I find that, what is it paired with?
10.
Yes.
Okay. All right. So that's how it works.
Okay,
All
what
right.
about f of g of 5?
Let's
Oops,
see.
you know what? Did I do it backwards again? I'm so bad about this. Okay, let's start this over. No, I did it right. I did it right. We did it right. Sorry.
All right.
That was,
Good.
there and then there, and it was 10. Yeah, we're good. Okay, now what about f of g of 5?
F of g of 5.
What are we going to find first?
F of 5.
Okay, wait. On B, remember you always work your way from the inside out.
Oh, so g of 5.
So find g of 5 first. And what is g of 5?
10.
10, good. And now what are you going to do with that 10?
Plug it into f of 10. F of 5.
F of 10. And what is f of 10?
10.
Yep.
Apparently. Mix and match.